All right, welcome back, algebrists. Today, we are going to begin and get through a good amount of 2.5, where our entire focus in 2.5 is going to revolve around this idea of what we call completing the square. Now, a part of what we're going to do right off the bat is going to be to kind of review how do we actually do this. We are going to encounter problems today that we cannot solve with factoring. We can't group it. We can't do anything there. We're going to need a new, more complex technique. Now, the cool thing about what we do today is it immediately leads us to what is known as a quadratic formula. If you guys remember ever learning the quadratic formula, we're going to see where it comes from in 2.6, but we're going to knock out 2.5 first. And here we go. In 2.5, completing the square, just right off the bat, our first little topic is just going to be making a perfect square trinomial. Now, we have a shorthand for this. Anybody recall what the shorthand for perfect square trinomial is? PST. Okay. We're just going to be trying to make our nice perfect square trinomials. Now, I'm going to leave a little bit of blank here, and I guess we'll finish it off. We'll leave a little blank space here. But here's my first little comment. When we actually go through making a perfect square, we're completing it. That is what we're doing, just for the record. Okay, so let's look at this, and we're going to just start off. We'll come back and put one little thing in here. Given something that looks like the following: x squared plus bx equals m, which this kind of looks like our regular stuff. Normally we use ax squared plus bx plus c. What's a in this case? So kind of, it's ax squared. What's the number in front of this? 1. So this is 1x squared. I still have a bx, and it looks like c might have been this other value over here, but we'll deal with that. If we get this, we can make a perfect square trinomial, which I'm just going to use PST there, by adding, and I'm going to pause, and I'm just going to leave it a blank for now. We're going to write a blank here to both sides of the equation. Now, we are going to work up to this, both sides of the equation. We're going to work up to this, and we're going to play around with a couple of them. And what I want to do is I want to see if we can't find the rule here, and we'll generalize it. We'll come back and we'll fill in this blank space in like 5 minutes. So we'll pause here, and I'm going to put a couple of these ones from the bell ringer today, and I'll be referencing them back and forth. But let's just do an example, and I want to make perfect square trinomials. And I know it's going to be strange here, but we're going to see if we can't tie together with an example that we had on the bell ringer, something here. So I know one of the examples from the bell ringer was x squared plus 12x plus 36. Okay, we want to use this, and I can put a couple more here, but I want to see if we can come up with the nice shortcut. So for our first one, all we're doing is filling in the blank. And here we go. I want to have x squared plus 2x plus blank. Okay, the only question right now without any additional guidance is how do we get that blank number? Now, if we look at the bell ringer, I'll get the exact ones. It was actually minus, but that's okay. We had x squared plus 6x plus 9. Okay, then we had x squared. I'm just making up more. Let's say plus 5x. I'm going to change that. 8x plus 16. These are all perfect square trinomials. Now, Deck shouted out a number right off the bat. I know that if I'm doing this based on the bell ringer, if we want a perfect square trinomial, that ending number had better be a nice square number, right? It could be 1 or 4 or 9 or 16 or 25, something that's easy to take a square root of. Declan, what did you suggest right away for this one? 1. Sorry, for this one. Declan thinks if we put a 1 here, it works. Does it?
I think so.
Well, let's check. Let's do the exact same thing where we're also going to review this factoring. Declan suggests a 1. Anybody have a different number to try? A 4 would be the next natural thought. Let's see if 1 works first. Okay, if we try to take a perfect square trinomial, and I'm just going to try to factor it to see if it works. Okay, first one. What is the square root of this? What's the square root of this? If you multiply these, you get 1x, and double it, you get to this. So is this a perfect square? Is this trinomial a perfect square? I think so, because we can factor it like this. Now, I don't know how Declan did this. I don't know if he guessed and checked, or if he saw something else.
Grouping. I looked at it, 1 times 1 can make 2.
Okay.
That's the same way.
So I think so, but we're going to refine that a little bit, okay? But I like that. Let's try another one. I don't want to do the exact same things, but let's do x squared plus 24x. Now, I like what he's thinking. If you didn't catch what Declan said, and there's a plus something, we just don't have it. Declan said he's thinking about grouping. Now, if it's a perfect square, we're going to find the same number on both of them, right? So let's just think about how we get here. We check to see if that square root and that square root exists, and then we multiply these and do what to it? Double it. Now, let's see, could we go the other direction? Instead of doubling it, what's the alternative? If you took, on this pink example over here, if you took 12x, or just 12, the b value, and divided it by 2, what do you get? 6 squared. It's 36. On this one, if you took the b term and divided it by 2, what would you get? 3, and then if you square it, because we're just undoing it, right? Instead of multiplying and then taking the square root, or square root and then multiply, we are dividing and then squaring. We're just going the opposite direction. If you took this and divided by 2, you got 3 squared is, and what's 8 divided by 2?
4.
Squared? Hey. If we try it here, what's 2 divided by 2? Squared? 1. What's 24 divided by 2? And now square it. So I think it's 144, isn't it? Okay. Now, there is a shortcut. If you recognize that we're just going the opposite direction, this is really easy to generalize. In this example, right here, we say that we just take this and do what? Divide by and then square it, right? Let's do one more just to see if it works. Also, not really relevant to the math stuff, but that is the most unique hiccup I've ever heard in my life. But let's do one more. X squared plus. Ooh, how gross of a number do we want?
When my mouth is open, it sounds like squeaky toy. Sounds like
140, those are huge numbers. Let's do 20. What do I need to add here to make this a perfect square trinomial?
divided by 2.
I'm getting 100. Where are you multiplying?
I thought you said. Oh, never mind. Just kidding. I got it.
How do we come up with 100 so quickly?
Divide by 2 squared.
20 divided by 2 is 10. Squared is 100. Now, in this general case, this was b and b and b. Every single time, we simply took b and divided it by what? 2. And then we did what to this? Squared. This needs to get filled in your notes. This is the answer. To complete the square, we simply make a perfect square trinomial by adding b over 2 and then squaring it to both sides of an equation. Now, we haven't solved any equations here, but we can immediately jump into using this to help us solve. Do we need to do another here? It almost sounds like an animal, but I don't know what animal I would say it sounds like. Really random thing. So we're going to use this. Now, immediately, this process where we add this, I want you guys to add this to your notes. This right here by making it a perfect square trinomial. This is what we call completing the square. This is it. Completing the square. By adding this clever choice of b over 2 squared, we now make a perfect square trinomial, and each of these factors super duper nicely. Okay, the process, if we do this, then we shouldn't use grouping to factor it anymore. We should just simply use completing the square to solve this. So let's keep kicking forward. So immediately we get a new lovely section here, and let's use completing the square as follows. We're going to be solving equations with two things, or with, I'm going to say completing the square, with completing the square, and the square root property. Okay. Now, for these, we're going to be solving equations using this technique. Now, remember that equations are just balanced, right? So, for example, we've talked about this last class, but I really want to stress it. If I add something to the left side of an equation, it's okay so long as I also add it to the other side. That is the additive property of equality is what we call that. Can I subtract stuff from both sides? Yeah. Can I divide both sides? Yeah. Can I multiply both sides? Yeah. Can I take square roots of both sides? Yes, as long as I do it to both sides, I'm allowed. The only thing I can't do to both sides is divide by 0. Like, that's the only rule. Okay, so check it out. We are going to work through this one, and we're going to solve each of the following. Now, immediately, you're going to see that all of your factoring is dead, and it just doesn't work. And we're going to make sense of that. So there's two approaches here, just so you guys know. We'll use both of them because one of them is going to align more naturally with your train of thought, but they're both doing the same thing. I'll let you choose which of them you want to do. They look a little different, but it's the exact same. So here we go. To begin with, I want us to solve the following. I want us to determine when is it true that x squared plus 8x minus 3 is equal to 0. Now, we are going to run through just the old-fashioned way. And the good news is that even though factoring will ultimately fail us here, it will very seldomly happen. What is always the first thing we check? Is there a GCF between x squared, 8x, and 3? Bummer. Nothing other than 1. Okay. Is it a binomial? Is it a trinomial? Okay, and there's something awesome about this trinomial. That it's 1, right? So all of a sudden, you're probably looking at this and you're thinking, oh my gosh, this is going to be so easy. Holloway, shut up. I'm not going to complete the square. That's dumb. I don't know if you're really that harsh about it. I don't know. You might be, but here's my challenge. We can try. Find me factors of -3 that add up to 8. So it's not 1 and 3, and it's not 3 and 1.
3 times root 3.
Okay, so before you get too crazy with it, we don't have any, right? Like, do you guys agree we can't find those numbers? Now, I'll tell you, they do exist. I think, and I'm confident that they exist, but there is an almost 0% chance that you would ever guess that number. And we're going to see why. If we can't factor this, and I'm going to pause out. If we can't factor by grouping, which shortcut is grouping, then we need another approach. This requires, what do you think we're going to call that new approach? We can't group it. What's today's whole focus? This requires completing the square. Now, for these, there are two ways that we can do it. And again, I just want to stress, they're both valid. I get it. Cool. Check it out. First one, we have an option. And I think that I'm just going to say this first time. If I wanted it to look more like what we wrote above, could I make it so it's only things with x on one side? Could I make it so that this only has x on one side? I'm going to add 3 to each side. Now, I'm not going to be able to annotate because I wrote this other note, but I think that it leaves us here. X squared plus 8x equals 3. Everybody okay with that?
Couldn't you just make the equation bigger? How do you get it?
Depending on what you mean by that.
Add something to both sides.
So yes, and if that's how you see it, I'm fine with it. I'm just going to show both ways because there's two ways that do the same thing, but one of them is going to be more natural for everybody. I agree with you. You might already be doing that. Okay, now, can I add the same thing to both sides of an equation?
Yes.
And if I wanted this to now become a perfect square trinomial, which that's the goal, how do I decide what I'm going to add? So just like the examples we did before, where you guys were able to tell me is 1 and 144 and 100, forget about the 3 for now. What do I need this side to be so that this is a perfect square trinomial? So we take b, which what is it here? 8, and we divide it by 2, and then we square it to both sides. Okay. Now, I'm going to add 16 and 16. As long as I do it to both sides, I'm okay. Now, at this point, it is hard to do this, but I'm just going to say trust. We've made it a perfect square trinomial. We don't have to go through the whole process of grouping again. We have chosen this last number to be exactly what we need. To factor this, as long as we add b over 2 squared, this thing factors super duper nicely. Now, I'm going to rewrite this in case you need the detailed steps of perfect square trinomials. I'm just going to rewrite it all in red at this point. Okay, to find a perfect square trinomial or to factor it, you guys are going to help me come up with these steps. When I take the square root here, I'm just going to say square root, and we'll just make these steps, square root of a x squared and c. And I'm using a and c specifically from this form, ax squared plus bx plus c. Is this a clear annotation? We find the square root of the first term and the third, because we'll get there. Use sine of bx. So, and then we'll clean this up. And then finally, write with squared. Something squared. Now, this is how I would, like in the fewest possible words, make sense of what we were doing when we factored them. Okay, check it out. Could you take square root of this?
X.
Everybody cool with x? Okay, so there's x, and the square root of this? 4. And notice, we already knew that, even if we didn't want to think about it like right now, because we took 4 squared is what we got here, so of course the square root is 4. And then the term in the middle, what's the sign of bx here? Plus? Okay, so now I'm going to do this in a different line. This is x plus 4 squared equals 19. Does everybody agree with what we've just done? And are these concise and clear enough to give you the shorthand for factoring a perfect square? Square root of the first and the last, sign of the middle, and then write it with a square.
That step is how we make a perfect square.
Not how we make it, but this stuff right here is factoring.
So is that the final answer then?
Not almost. Because if we're trying to solve, have you told me the x values yet?
-4.
That's only if it's 0.
Oh.
But check it, because nothing crazy has to happen here. Now that we have this, we've factored it. So here is make the perfect square. Here is the factorization. Now let's solve. How do you solve for x if it's stuck inside a square? We got to undo that. We can't do that yet because it's stuck inside of my square. My exponents happen first, right? How do I undo a square? Yeah. Of which side? Square root of both. I'm sorry? So this is just how we factor the perfect square trinomial. So here it's factored, and now we're going to solve the equation. Because this is solvable all of a sudden. I'm going to take the square root of the left and the right. I'll do the left. It's x plus 4. Anybody know the square root of 19? Me neither, but there's something that has to go in front of it if we're introducing a square root. All of your answers on the weekend homework had plus or minus for some reason. Because, yeah, you not just 19,
Root 19.
root 19. We took the square root, we added the plus or minus. I've done square root of both sides, I'm sorry. Okay, if we now want to solve for x, we're one step away. How would I get to just x equals something? I'll subtract 4 from both sides. Minus 4, minus 4. And these ones, they're going to look ugly for a moment, but I assure you that there's a reason that I would encourage you to do this. I think that this is what our answer is. How many answers do I really have written here? So I could see both arguments. If somebody claimed 2, can you convince me of that?
Yeah.
Why?
Because there's 2 x intercepts.
So, but I only wrote one thing. How do you mean there's 2?
Because it's the same.
I don't think they're the same. Now, looking at this, and I'm glad I asked that question because I think that you're on the wrong question, and maybe I just need to ask it better. There's 2 numbers here, like not just this and this, but there's 2 really ugly decimals. Do you agree that one of them is -4 plus the square root of 19?
And one of them's -4 minus square root of 19.
And x is -4 minus the square root of 19. Now, this, I don't really care if you write both of them like this. I don't mind writing it in a single line right here, but I want to be very, very specific. When you are giving me answers and stuff, unless you have to actually plot the point, these are the answers that I want. I actually prefer the plus or minus, but I'm okay with this. These are exact answers. Now, if we had a reason for it, somebody may reasonably give me the following instead. And this is that same question that we had, and I think we had exact or not in our notes last week. If you were telling me to cut a piece of wood and I said how long, and you said -4 plus root 19, I'd tell you you're stupid, just for the record. Stupid's not the right word. That was like overly rude because it has nothing to do with them. I'd tell them, no, give me a real number. And what I would mean by that is somebody might give me this instead. 4 plus root 19 is 8.3589. And this goes forever. 3589. It never repeats. Or it'd be a negative. And I'm actually wrong already because that was a negative. So we'll just make that negative. That's easy enough. Or it'll be that, gross, or 0.3589. 0.3589. Which of these answers do I want? The exact or the approximate? 0% of the time do I want the approximate. I would rather not pick up a calculator to have to do this. Cool. Should we do one more? I'm going to do one more like this, similar, but we're going to do it a little tiny bit different where you can pick your flavor that you want. Cool. All right. Questions here before we move on? We're going to do another very similar problem. Does anybody who wants this factoring a perfect square have it? Okay, if you don't, it'll still be on the video. You guys can watch it while you're smashing the like button. Cool. All right, one more that I'm going to work us through. Very similar problem, but I want to approach it a little bit different. Okay, let's say this one instead was x squared minus 6x, just kidding, minus 2x plus 3. And let's see if this one works. Oh, fantastic. You're going to be tempted, and really we're just filling up our tool bag right now. If I just gave this problem to you without any further direction, you're probably just going to try to factor it, just regular. Now, is there a GCF? Bummer. Is it a binomial? Leading coefficient is 1, which is super convenient. Can you guys find factors of +3 that add up to -2? So if -3 and 1, those multiply to be -3, but we need a +3. Yep, they multiply to be +3, but add up to a -2. Like it's either 1 and 3, which adds up to 4, or it's -1 and -3, which adds up to -4, right? I can't do it. Now, in the first problem here, right off the bat, we added the 3 over so that we just had a blank space to fill in. So before we do that, like on this one, I would just subtract 3 over if we did it the same way, right? Now, if we want to view a different way, can you guys tell me what that 3 needs to be in order to be perfect square. Like the same question applies. If we take b, what's b in this problem? So what the b is just 2, right? Divide it by 2 and square it. I could subtract the 3 and then add 1 to both sides, or, and this is very similar, but maybe this is how we view it. If we can all agree, and this is same type of problem, just slightly different approach. We need this to be 1. Now, on our first problem, again, we just moved it over and then we said, let's just fill it in. But check this out. If we need this to be a 1, is there anything that I could do in one quick, easy step to make this a 1? If we subtract 2 from both sides. Notice, nice job, by the way, Lucy. Notice what happens. X squared minus 2x plus 1 is now equal to negative 2. Similarly, on this line, if I knew that this had to be a 16, instead of adding it and then doing that, if I knew it had to be a 16, could I just added 19 right here? And would we have still got the same thing, 16 and 19? I don't care which way you view it. One of these probably feels more natural. I think I like this one more, just 'cause it's a little bit faster, but we're doing the exact same thing. This is just one less line of work. Okay, we've made this now perfect. I'm going to give you about 10 seconds. I want to know what goes inside these parentheses. Does anybody second x minus 1? Square root is x. Square root is 1. And the sign is minus. I will second it. Is it worth knowing the perfect square trinomial trick? Yeah, like really you could get by with just grouping, but this will save you time over grouping still. Now, before we move on, questions about how I got here? Lucy.
Did you square root x squared and negative 2x?
I didn't touch a negative 2x. I took the square root of this one, and I erased the red stuff here, where it said take the square root of ax squared and c.
So where did 2x?
So natural question, it's just hidden. And I'm going to show that for you real quick. You don't have to write this, okay? Do you agree that x minus 1 squared literally means this?
Yeah.
Now, I'm going to argue that the 2x, this is what it means to square something.
Oh, yeah.
And I'm going to argue that 2x is in here. It's just hiding because it's in this factored down form. X squared minus x plus 1. When I expand it out, is that negative 2x actually in here? Yep, we just don't have it right now. It is there. It's just in its factored form. It's no different than me saying, and this is a nice analogy. If I said 18 is 2 times 9, do you agree with that?
Yeah.
But then I said, no, 18 is actually 2 times 3 times 3. You might ask, where did the 9 go? It's still in here. It's just hidden in the same way. Yep, cool. All right, so once we get here, the rest of the problem's easy. If I want to solve for x, what do I do to both sides? So what's the opposite of squaring something? I'm going to take the square root. I'll do the left. Here it is. This right side of this, super important that we don't forget this. What's before I write anything? Plus or minus. Now, I'm going to take one more step ahead because negative 2, I can already tell there's going to be some trouble. Is negative 2 negative 1 times something? Good. They're not adding, they're multiplying. Why would I take the time to write this out?
Isn't there a 1 on the other side too? Oh, no.
Ooh. So, Declan, I'm not sure what you mean about the 1. I already have it. I just haven't moved it yet. I'm just taking square root in this line, but I agree with you. I heard somebody say the right answer. When I see the square root of a negative 1, I is there, and I can tell it's there. So I'm going to take the square root of negative 1, and you guys just told me that was what?
I times 2, so 2i.
So careful. Just do negative 1 first. I. What's the square root of 2? Yeah, I don't know it. It's just root 2. And then notice I'm doing little steps here. I still have an x minus 1 on the other side. All I have done is dealt with that imaginary number. there's only one more step to get all the way through. What would you have me do to both sides? I will add 1 to both sides, and I'll just make sure I say this, square root, simplify. And then here we'll add 1 to each side. And I'm always going to write the number first. 1 plus or minus I root 2. A plus BI. Now this one looks like IB. You can put your imaginary out back if you want, but huge warning signal if you do. Okay, these problems, do they feel okay? All right, we have 7 minutes. I want you to like legit try the first few. We have a super short assignment tonight, 6 problems. 6 problems is it. One little thing I do want to remind you of, and if you want to put this, you can. What is the square root? If I want to do this, the square root of A over B, can I split this up? The square root of A divided by the square root of B. I think, and I hope I'm right. If not, it's not going to hurt. But I think that this was the only thing on the homework that gave first hour issue when they saw it, was forgetting that that was a thing. Okay, so for right meow, we'll go back over here and we'll go to our class, 6-hour Algebra 2. Sweet. Today is the 20th. You will get homework 2.5.1. You will find this waiting for you lovingly on page 96. And you get problems 18 through 23. Okay. I'm not going to tell you what the other classes said yet, but I do want to propose something. Seating arrangement in here. I'm never going to make you guys pick seats. Like, you guys have kind of navigated over this way, which I do appreciate. Even with that on, it still happened. Okay with rows, or would you like to suggest something else?
Like
A circle.
So it'd have to be like a half circle. I could do a half circle where, I mean, we're all sort of like the same half circle, so that's a weird one for me. Thoughts? Like, I don't prevent you from moving stuff now. Let me think. All my other groups said just keep the rows, except one of my gigantic classes said they want groups of 4, which I hate that idea. And I know, like, I've done it before, but I'll tell you, if I was a student in class and I'm in this desk because I'm working with them, I am like pissed off that I have to come in here every day and do this. Like, that's the only thing about it that I don't like. That's fair. Okay. Well, I'm going to tell the other class that suggested a change that democracy won and very few people agreed with them. Cool. I'm fine to keep it. We can always move desks in here as we see fit. Cool. I want you guys to get started on it. And David, we should probably chat real quick.